Okay, ladies and gentlemen, welcome back to Forces Lesson 4, Physics of an Inclined Plane, Part 2. Now, here's another question. Bob, 70 kilograms, is skiing down a 30% incline. The snow is dry and the skis are hickory. What's Bob's acceleration? So, draw a picture. There's Bob on his skis going down the incline. Now, from the way I've drawn the picture, let's tilt our head, force of gravity parallel. I know I've drawn the ramp going the other way, so my forces are going backwards from what I normally do. Force of friction, mu mg cos theta. Force normal, which is mg cos theta. And force of gravity perpendicular, mg cos theta. So, he's not going up, he's not going down, he's going sideways. So, F net is the sum of the forces. It's force of gravity parallel plus force of friction. So let's plug some numbers in. That's mg sine theta minus mu mg cos theta. So we know Bob's mass, 70 kilograms. We know acceleration due to gravity, g. We know angle, 30. We don't know mu. So let's start plugging numbers in. 70 kilograms times 9.81 meters per second squared times sine of 30 minus mu. Okay, now let's read the question again. Did I list mu? No. But I said the snow is dry and the skis are hickory. That's suspiciously accurate. So do we have waxed wood? Oh, we do. Waxed wood on wet snow, waxed wood on dry snow. Now let me reread the question. The snow is dry and it's wood. So, wood on dry snow, mu kinetic, he's moving, 0.04. Okay? So, mu is 0.04. Real slippery. Times 70 kilograms. 9.81 meters per second squared. Just move this over a smidge. The advantage of using a computer times cos of 30 degrees. Okay. Cannot do this in my head. I'm not going to try. But you grab Mr. Calculator, follow along with me. This should be, when I calculate it, I got 343.35 newtons. That's pulling down the hill. The force of friction opposing that is 23.8 newtons. What I got. So I got F net is 319.55. That's the net force. Now, that's F net. But the question is, what's the acceleration? All right. Acceleration is F net for mass, 319.55 newtons, divided by 70 kilograms. And I got 4.6 meters per second squared. Yes. That's scary fast. That's a lot of acceleration. Bob is going boom down that hill. Yeah, that very quickly gets very bad. All right. Now, if you don't believe me, pause the recording, double check my math. Well, actually, you should have a calculator. I'll be calculating it anyway. Now, if some of the snow melts and it becomes wet, what's the new acceleration? Well, remember back here, we just looked at this and we went, oh, waxed wood on wet snow. let's know a different coefficient of kinetic friction, more friction. It's actually better for be dry. Something about the ice crystals, but anyway. So, F net, force of gravity parallel, plus force of friction, mg sine theta minus mu mg cos theta. So 70 kilograms times 9.81 meters per second squared times sine 30 minus 0.1 times 70 kilograms, 9.81 meters per second squared times cos 30. Now, somebody always asks, but that 9.81 is acceleration due to gravity. Yes. But remember, we're dealing with directions here. From the way I drew it, force of gravity is going to the right, so that's positive. Force of friction is going to the left, opposite, so that's negative. Now, all you have to do is remember that this, since it's going downhill, is accelerating, so it should be positive. I know, that's counterintuitive. Anyway, so that's 343.35 newtons. Again, now the coefficient of friction is a little bigger, 59.5 newtons. That's what I got. Check my math. So that is 283.85 newtons is F net. Now, as I said, check my math because I'm old and I screw up way too often. So, net force is 283.85 newtons divided by his 70 kilograms. That's only 4.1. Only 4.1, but that's still noticeably less. Okay. Now, we've done a lot of these. Sorry, I'm just going to pause for a sec, make sure you got it. And of course, I'm going too fast, pause the recording. But I want to get through this video. So very quickly, if the slope is constant 30-degree incline, 250 meters long. If the snow stays wet and the skis are hickory, what's his final speed? Woohoo! We have a V initial, the final acceleration displacement time question. Now, stays wet, so that's 4.1 meters per second squared. What should his V initial be when he's skiing? It should be 0. Now, displacement is 250 meters. So what's V final? Oh, I should have drawn a picture. My apologies. There he is going down the hill. We don't have time. We don't need time. So we use the final formula, velocity final squared equals velocity initial squared plus 2AD. Final squared equals 0. 2 times 4.1 meters per second squared times 250 meters. So, double check my math. 2027. The square root of that. 45 meters a second. Holy crapola. That, well, times 3.6, he's doing over 150 kilometers an hour. He really better not hit anything. So, slow down. Slow down. And I don't want to do the medical co-response for that. Not good. All right? So, typical question. We've done a bunch of these. You've shown me you can do it. I don't want to really do anymore. But, last question. What mu or coefficient of friction will keep Bob at rest? It's the spring or the fall. He hits a rough spot. He hits some dirt. The snow's thin, so he hits some dirt. Higher coefficient of friction. What mu coefficient of friction will keep Bob at rest? Now, remember we've gone on about this, so force of friction, force applied. So here, at rest, so that means at the start, he's in a rough spot, he's not moving. Force net equals force applied plus force of friction. Or, sorry, I shouldn't be saying applied. That should be force gravity parallel plus force of friction. Now, to be at rest, that means velocity is 0, that means acceleration is 0, means net force is equal to 0. So that means force of gravity parallel equals force of friction. So, mg sine theta equals mu mg cos theta. Okay? Yeah, one of them is supposed to be negative. I'm just lazy. Equals sine of theta or cos theta. Sine of 30 degrees over cos 30 degrees. And I'm getting 0.577 or 0.58. So if he hits a real rough spot, lots of gravel and crap, he won't move. He doesn't move. The net force, he has 0 acceleration. Velocity, acceleration is, net force is 0, acceleration is 0, velocity is 0. All right? I'm going to be quiet because I'm starting to blather, but this is what I expect you to be able to do. Any questions, shoot me an email. Otherwise, good luck.